sine, and cosine at present, yes. Okay, so this is review. If the blanks filled with sine and cosine, amplitude value of A. How do you find period? 2 pi over B. Technically, we absolute value it, but you're not hardly, they almost never give you a B with a negative on it, so it's not an issue. Then, on your chart, do I have phase shift next?
Yep.
Okay. How do you find phase shift?
Negative G over B.
Yeah. You can write it to me, write it either way, whichever makes more sense to you. You can write it to me that you got to set the quantity equal to 0, or you can then actually solve it and say it's negative D over B, whichever way you like it. And then last but not least, what was the vertical shift? It's the letter C, yes. Now, we did secant and cosecant. Did anything change?
Amplitude.
Yes. What was amplitude?
NA.
Technically NA. It doesn't apply because there is no maximum distance. It's not a wave. It goes up forever. You can't have an amplitude. But that number in front still affects our graph. Okay, was period still the same? Yes, period was still the same. Phase shift still the same? Yeah. Okay, can phase shift and vertical shift ever change? It's been the same for every graph we've ever drawn. It's always, the number added on the back has always been the vertical shift.
Until now.
The only difference with phase shift is the fact that we've always had, when we were graphing x plus a number, x minus a number, we never had 2x plus a number that we had to deal with. So, little more issue to solve it, but not that big a deal. Alright, today we're going to add tangent and cotangent. We will come back and add this in here shortly. Two things change on tangent and cotangent.
No.
So since we just decided it can't be phase shift and vertical shift, must be amplitude and period, huh? Because these two never change. It's always the same. But first I got to get you to realize what a lovely graph of tangent and or cotangent looks like. So we're going to go actually draw it. Can I switch? Okay. So I want to graph just ordinary plain tangent. Okay. Zach, I lied to you. Here's the one time. All right, who can recite the tangent column of the special angle table to me?
Tangent is going to be square root 2. Oh, wait, no.
0.
You want these in radians.
I want these in radians. 0, 6.
Square root of 3 over 3, and then it's 1, and then square root of 3, and 5.
All right, that was good. It was a fight. That was even better. Okay, so those are the points I'm about to plot, since those are the ones we know so well. Okay, so tangent has a point at 0, 0. Nice origin-centered point. If I go over to pi over 6, that tick mark that's not labeled. Okay, you got to know where's square root of 3 over 3. Square root of 3 over 3 as a decimal is about 0.56, so just a smidge over a half up. So pi over 6 seems close there. Pi over 4 is the nice one because we get it plotted at 1. So pi over 4, 1 up we like. At pi over 3, square root of 3 is about 1.7-ish as a rough decimal. So if I go to 1.7, that's going to be up above. And then lastly, at pi over 2, it's undefined. Asymptote. When it's undefined, that means it's an asymptote. So pi over 2 is an asymptote. And I have this curve that just goes curving up toward the asymptote. Okay, that doesn't look like the graph that's on that worksheet. This is one of the rare cases, the other half of this graph's on the negative side. So I need to plot the negative coordinates over here, too. So if I went back through this thing and I threw a negative on all those coordinates, would the values change? If it's pi over 6, it's square root of 3 over 3. The question is, the only thing that could change is it positive or negative. So if you're going to negative angles, which means you're going around the clock backwards, that means we're going down into the fourth quadrant. What's tangent in the fourth quadrant? Negative. So if the angles go negative here, all these values go negative. So you get the exact same points we just plotted, just negative. So I'll be left pi over 6, down 0.56. Left pi over 4 is down 1. Then I'm down 1.7. And at negative pi over 2, I've got another asymptote. And I'm in different colors, sorry. So if I play connect the dots, it curves over here and it comes down. And it looks a lot like a scrabbler. Not exactly the same. A scrabbler's got a kind of a more sudden, definite bend there. This is a little more subtle bend, but if you think kind of Scrabble-like, that's a pretty good idea. Okay, so my question to you is, what's the period of that graph then? How long, wide is that?
It's 1 pi.
How did Luke get 1 pi?
2.5.
Yes, it's a half and a half. So that makes a whole. So yeah, period on a tangent is 1 pi, not 2 pi. So when we go back to our chart, and I want to fill in period on tangent, it's pi divided by b rather than 2 pi divided by b. That's the big change. So 1 pi if you're doing tangent or cotangent. Okay, while we're here, does it have an amplitude?
It doesn't have a height because it's not really a wave.
It's not a wave. Does it have a maximum height off the x-axis?
No, it would be
Yeah.
NA.
It's another NA, yes. No,
Not apple.
it doesn't apply. There isn't an amplitude because there isn't a maximum distance. It's not a wave. Yeah. Okay, but here's the kicker. If I throw a 4 in front of it, what's it going to do to it?
Does that make it like
Okay.
wider maybe?
Okay, technically what it does, when you put a number in front, it multiplies all your y coordinates times 4. So, okay, which one of these y coordinates would be the easy one to take times 4? 1. And if you'll notice, pi over 4 is the point exactly halfway between the center and the asymptote. So that point that's halfway, I wanted black, dude. It doesn't want to go to that color. Okay. That is exactly the halfway point. So when we plot our 5 points on a tangent, your 5 points are going to be the center, the halfway point, the asymptote, and then do the same thing on the other side. 1, 2, 3, 4, 5 points. That's the 5 points you're going to plot on the tangent. So we're going to plot this point that's normally at 1. If there's a number in front, then that point would be up at 4. So it would stretch this graph out. It would be a much straighter tangent. So that number affects that point at 1. That's where we're going to change it at.
That's what would be up at 4.
That would be up at 4, yeah.
So is that the only point where you're going to change?
That's the only point you're going to change. Otherwise, you're going to have a center on the axis, and you're going to have asymptotes.
Are tangents going to be the easiest graph?
Once you get used to them, yeah. Okay, realize, does it just stop? Does it just do this once? No. It does this, and then it starts to repeat itself. Tangents and cotangents repeat themselves as well. So once I get on the right side of this asymptote, and actually, let me ask you this, where would the next center point be? If the center was at 0, and the period is pi, the next center, yes, the next center is at pi. And there's a center after that at 2 pi. So where's the next asymptote? If this one is at
3
a
halves.
half, so then it has to be at 1 1/2, or in other words, 3 halves. So the next asymptote would be out here, and then there'd be one at 5 halves, 7 halves, 9 halves, etc. And then the only points you would actually have to plot, you would find the halfway points between there, which are our fourths, and you would be down 1 and up 1 each time. Yep, the asymptote's at 3 halves. Okay, the hardest thing people struggle with on tangents is drawing the curve right. Okay? I don't want a squiggly line. This is what I get. People see this, they go this way, then they go this way, and then they come down here and I get squiggle. Does that look like this? No, don't do that. If you have a squiggle, you're wrong. Away. If you start at the center to get to the upper point, curve under. And then you're going out toward the asymptote. When you're going down, curve over.
You really only technically need to plot like 3 points.
You're only, as far as drawing the graph, you need those 3 center points, and then you'll have your asymptote. Yeah. So, just don't make me squiggle. All right? That's my request. And that's tangent. Okay, now, we have to note something important. When you have a phase shift on a tangent, phase shift shifts whatever is at 0. On a tangent, what's at 0? The middle. The center is at 0. So if you have a phase shift that phase shifts to pi over 3, the center is at pi over 3. You will then have to find 2 points on the right and 2 points on the left, because the center is going to be at that number. So that's really, really key. We need to add that to our list here. Tangent shifts its center. Okay. So the question is, how do I get a cotangent? It's a really similar graph. Because,
Same thing, just going the opposite?
well, kind of, sort of.
What's on the y?
Don't we know cotangents is the reciprocal of the tangent points if you flip them over? Yeah. So, you're pretty close. The other way with some changes. If this is 0, what's the reciprocal of 0?
0.
Undefined.
0 is 0 over 1. So actually here, let me just, if you're doing cotangent, 0 becomes undefined.
Cotangent. Not tangent.
Okay, so all you're doing is you're taking all of these points and flipping them over. So if you do the reciprocal of 0, you get undefined. If you get to do the reciprocal of square root of 3 over 3, we know it becomes square root of 3. We know those two reciprocals. So you get the 1.7. The reciprocal of 1 is 1. The reciprocal of square root of 3 is square root of 3 over 3. So it's back to the 0.56. And then lastly, pi over 2. What's the reciprocal of undefined? 0. So can you figure out what that's going to do to the coordinates?
It's going to put me an asymptote in the middle.
Yeah.
Everything's going to go to the middle and straight up or down.
Every place tangent has a center point, cotangent has an asymptote. And every place tangent has an asymptote, cotangent has a center point.
What?
So I wish what would be a color I could write over with that y'all would see?
Orange. Orange. Do orange.
Orange? You think that's my oranges aren't that bright, but we'll try. Green might be better. This one doesn't.
No, it's neon brown. Neon brown. Neon brown.
No, go up.
Green? You think you can see neon green?
Try it.
Okay, so every place this is a 0,
No.
you can't see that, can you?
No. You have to do like purple or like neon brown. Pink. Or brown. Just do
The
black.
neon bright pink? You see that?
No. Just do black and make it thicker.
I could do thicker. Good idea.
Hey.
Thicker.
Make it.
Thicker. Good idea. Black thicker. Okay.
Oh.
Sorry. Okay, fine. Thicker. All right. So if you're doing, well, okay, how's about neon green thicker? So every 0 is an asymptote. Every asymptote is a 0. We'll get, once I get it drawn here, you'll get it in a second. So then,
Are we supposed to do it on the same graph?
you don't have to, I just want to make my point here. The points that were at 1 and -1, they stay the same.
Oh, okay.
So can you see what the curve's going to do? Yeah, it just comes down. So a cosecant just falls when a tangent rises. How do I, what now? Those are the 1 and -1 points you already had.
Does 1 point stay the same then?
Those stay the same, yes. The 1 point stay the same. Okay, what you all need to know as far as doing a cotangent, you just need to know what's at the origin, what's at 0. The asymptote. So therefore, when you start drawing a cosecant graph, you start with the asymptote. When you draw a tangent, you start with the center point. That's what you got to keep straight. And then just know that cotangent falls.
So it's like this?
Pi over 4, 1. Yes. Yeah, 3 pi over 4. Okay. So, yeah, comes down. You'll never do them both on the same graph. So, I'm still in green. Whoa, no.
Right on the side.
Yes. 0 pi, 2 pi, yes. Ah, sorry. I just don't want that. Thank you. I'll write this and I'll quit. Okay. I'll write this and then I'll quit.
I don't believe her.
I meant I'll quit the recording for the moment. Okay. So tangent starts at the center, so tangent shifts its center point. Cotangent starts at an asymptote, so when it shifts where the asymptote starts.
Actually,